In 2010, inspectors at an Iranian nuclear facility noticed something strange. Centrifuges enriching uranium were failing at an oddly high rate, and nobody could figure out why. The cause turned out to be a piece of malicious code that had crossed into a network with no internet connection at all, and had already been quietly sabotaging Iran's nuclear program for months without a single person noticing. It's now considered the most sophisticated cyberweapon ever built, and to this day, no government has ever officially admitted to creating it. The story starts, publicly, in June 2010, when a small cybersecurity firm in Belarus discovered a mysterious piece of malicious software while investigating unrelated computer crashes for a client. But the real trail actually began months earlier, inside Iran itself. Inspectors from the International Atomic Energy Agency, visiting Iran's Natanz uranium enrichment facility, noticed an unusually high number of centrifuges failing and being replaced. By some estimates, close to 2,000 centrifuges were damaged before anyone understood what was actually happening. Iran's own technicians were baffled. Machines that should have run reliably for years were quietly breaking down, one after another, and standard troubleshooting kept coming up empty. The answer, once security researchers finally cracked it open, turned out to be one of the strangest engineering achievements in the history of computing. It's called Stuxnet. Here's the problem Stuxnet's creators had to solve. Natanz industrial control systems, the computers running the centrifuges, were never connected to the internet, deliberately, precisely to prevent exactly this kind of attack. In cybersecurity, that's called an air gap, a network so isolated it can't be reached remotely by anyone, no matter how skilled. On paper, an air gap facility should be immune to a computer virus. Stuxnet's designers solved that problem with something almost embarrassingly simple, a USB flash drive. The worm was built to spread automatically the moment an infected USB drive was plugged into any Windows computer, using a vulnerability so severe that simply having the infected file's icon visible on screen was enough to trigger an infection, no double-clicking required. The working theory is that Stuxnet initially infected computers belonging to outside contractors or engineers connected to Iran's nuclear program, then physically hitched a ride into Natanz on a USB drive, carried in by hand, by somebody who had no idea what they were carrying. Once inside, Stuxnet didn't behave like a typical virus at all. It behaved like it was hunting for something extremely specific. Stuxnet used 4 separate previously unknown vulnerabilities, what security researchers call 0 days, to spread and gain control of infected systems, an almost unheard of number for a single piece of malware. Most attacks use 1, if they have any at all. But the truly unusual part wasn't how it spread. It was how selectively it attacked. Stuxnet was engineered to search specifically for Siemens Step 7 software, used to program a particular family of industrial controllers. Even finding that software wasn't enough to trigger it. The worm dug deeper, checking for a very specific hardware configuration, a particular communication module attached to the controller, and evidence that the controller was managing motors spinning within an extremely narrow frequency range, roughly 807 to 1210 Hz. A range with almost no industrial use outside of one specific application: high-speed uranium enrichment centrifuges. In other words, Stuxnet spread indiscriminately, copying itself onto huge numbers of computers around the world, in Indonesia, India, and elsewhere. But it was designed to sit completely dormant and harmless on the overwhelming majority of machines it landed on, and only activate its actual payload on the tiny handful of systems that matched Iran's specific nuclear centrifuge setup almost exactly. And when it did find its target, what it actually did to those centrifuges was almost diabolically patient. Uranium enrichment centrifuges have to spin at extremely precise, carefully controlled speeds to function correctly and to avoid literally tearing themselves apart. Stuxnet secretly took over the industrial controllers managing those speeds and began periodically forcing the centrifuges to spin faster and slower than intended, in irregular patterns, subtly stressing the equipment and accelerating its wear far beyond normal. Here's the part that made it so devastating. While it was doing this, Stuxnet simultaneously fed the plant's control room monitors completely normal-looking readings, essentially a recorded loop of everything is fine data, hiding the sabotage from the very engineers whose job was to watch for exactly this kind of malfunction. It even patched the underlying programming files themselves, so that if a technician tried to inspect the code running on the controller, they'd see the original, legitimate program, not the malicious instructions actually running underneath it. Iranian engineers spent months replacing centrifuge after centrifuge, assuming they were dealing with a mysterious manufacturing defect or an unusually persistent mechanical problem, never suspecting they were watching a piece of software slowly and deliberately breaking their equipment while lying to their faces about it. By the time it was finally discovered and reverse-engineered, security researchers realized they weren't looking at ordinary malware at all. Ralph Langner, a German industrial security researcher, was among the first to fully reverse-engineer Stuxnet's code, and he came away convinced of something remarkable. This could not have been built by a criminal group or a lone hacker. The sheer cost, the specialized industrial knowledge required to understand uranium's centrifuge behavior, the 4 simultaneous zero-day exploits, the physical delivery method into an air-gapped facility, all of it pointed toward a nation-state, and likely more than one, working together with essentially unlimited resources and time. In 2012, New York Times journalist David Sanger published detailed reporting based on interviews with current and former American officials, describing a classified American program codenamed Operation Olympic Games, reportedly begun under President George W. Bush and continued under President Obama, developed in cooperation with Israel. According to that reporting, the goal was to quietly sabotage Iran's nuclear enrichment capability as a nonviolent alternative to a military strike, at a moment when American officials worried Israel might otherwise launch airstrikes against Iranian nuclear sites and risk a wider regional war. To this day, neither the United States nor Israel has ever officially confirmed building Stuxnet. But the reporting, combined with the code's own fingerprints, has left most cybersecurity experts with little doubt about where it came from. What makes this story matter today isn't really the specific centrifuges it destroyed. It's what it proved was possible. Before Stuxnet, purely digital cyber attacks were understood to be able to steal data, crash networks, or spy on communications. Stuxnet demonstrated, for the first time in public view, that computer code alone could reach across an air gap and cause real, physical destruction to industrial machinery, entirely without a single soldier, missile, or bomb. That distinction matters enormously. It effectively opened a new category of warfare, one where a national intelligence agency could disable another country's critical infrastructure, power grids, water systems, factories, using nothing but code, potentially without ever being definitively traced back to them. Security researchers have pointed directly to Stuxnet as the conceptual blueprint behind later attacks on industrial systems, including attacks on Ukraine's power grid that left hundreds of thousands of people without electricity. Once the world saw that this kind of attack was achievable, it stopped being a hypothetical, and every government with serious cyber capabilities took notice. Stuxnet ultimately damaged or destroyed close to 1,000 centrifuges at Natanz, delaying, though not permanently stopping, Iran's nuclear enrichment program. But its real legacy has almost nothing to do with Iran specifically. It's the demonstration that a sufficiently sophisticated piece of software, patient enough, specific enough, and well-funded enough, can reach through an air gap once thought to be an unbreakable wall and physically break something in the real world. Nobody has ever officially taken credit for building it. Nobody really needs to. The code itself already told the story. If this is the kind of story that makes you look at your own devices a little differently, that's a completely reasonable reaction. Subscribe for more deep dives into the moments where technology, quietly rewrote the rules of what's possible. And tell me in the comments, does knowing this kind of attack is possible make you more or less worried about the infrastructure you rely on every day?